We're continuing our conversation about bad graphs. Some graphs are bad. Some are potentially misleading. So let's explore some useful rules of thumb on things you should do and things you shouldn't do. For me, among the top things you should never do is make a pie chart. I'm exaggerating a little bit, but not too much. Pie charts are they're easy to mislead. They're easy to misdo. There's a statistician, a famous statistician, that says, in your life, you are granted 3 pie charts. Use them wisely. Right? Don't do pie charts. Pie charts are good for like rough proportions. If you want to show that something is a big proportion of the whole. But then that's about all it can do, right? If you want a particular number, it's not like it's obvious from the shape of the size of the slice. You'll need to put a particular number in there, almost by hand. Type it into the pie if your readers need it, kind of like we did with bar charts. Pie charts are horrible. Here's an example. What an absolutely horrible graph that is. This is supposed to show you how many procedures there are for surgery. Almost everything is wrong with this picture. I don't know what these little wingding type clip art stuff is. It's distracting. I can't tell exactly what these different things are. Is this orange different from this orange or that orange? Can't tell what's what. It looks like orthopedics is pretty big, and it looks like red, whatever red is. Is it ophthalmology? That looks kind of big. I don't know. I can't really tell. There's too many slices here and nothing's labeled. So again, this is Dark Horse Analytics, just a website I found, and they do some magic on some pie charts. So here we've got this pie chart. We're talking about the bacon industry. So they're going to want to focus on bacon. But this is all the different uses of pig meat. And let's just say that, this was your picture. This was your graph. How can we improve on it? Very easily. Get rid of all the clutter. And then send them maybe a bar chart. So you get rid of the background. Remove the borders. We've got a redundant legend there. This arrow is pointing to red. I don't need the red again. We can get rid of that. Right? The fact that this thing is 3D is actually extremely misleading. I'll show you a more obvious one here in just a moment, the very next slide. Just keep in mind that when you're doing 3D, you're visually, like subconsciously adding this blue part here to the blue slice. Really, the informational part, the proportional part, is just the top surface of this thing. The rest, all this part, is just visual adornment. But subconsciously, what it does is it makes the blue part look a whole lot bigger than it actually is. It's misleading. Let's get rid of it. So we rotate. Okay, now we've got something that looks a little bit more professional, and it's at least not misleading. We can do better. Get rid of the bolding. Again, if all we want to do is focus our reader's attention on bacon, then have that be the only one with a color. Right? We can, in fact, not do a pie chart. Look at that. A bar chart. That's nice. That's got great information. I can see 42 versus 14 versus 12 versus 32. It draws the reader's eyes to the one thing I want them to come away from. That's an impactful graph. So as promised, here's what I mean by why a 3D pie chart is misleading. Both of these pictures show the same exact thing. the labor share of income, so labor versus other. In both pictures, it's both 30%. This picture is doing two things to you. First of all, it's forced perspective. The fact that the front of this thing is closer to your eye makes it look bigger, right? Like, how big is my thumb? Now, how big is my thumb? I don't even know if that was in focus, but you can do it to yourself, right? When your thumb is right in front of your face, thumb looks big. Hold the thumb far out, thumb looks small. Same exact thing here. The front of those pies are right by your eyeballs, so they look bigger. And the second trick that this thing does, it's obvious here on the right. Your subconscious wants to add all of this blue to the top surface. So we see a whole lot of blue here. We don't see a lot of blue there. Your subconscious is adding this here. It's adding light blue to light blue. It's definitely not adding the light blue to the dark blue here. So, I mean, if you wanted to mislead people to make this thing look bigger, this is one way to do it. But now, hopefully, they'll never be able to pull that trick on you. Now, speaking of tricks, here's another very, very common one. It's using a non-zero origin. Now, this came up just the other day. Right? So this shows you the trend in Florida of coronavirus cases. Now, they're not lying with the numbers. I don't think. Presume these numbers are correct. Oh, no, wait. They are. Forget, this isn't even a non-zero origin thing. 4,000, why is that below 3,000? 4,000, 3,000, 2,000. The heck is this? I don't know. That's our news media for you. Now here is definite shenanigan about axes. You can squish down your axis like here or stretch it out. It's the same exact information between both of these graphs. But if you stretch out that y-axis, you pull up that line with it. And that seeming trend looks like it's skyrocketing. Or I can squish it down, and then it's much more like a horizontal line, and it doesn't look like it's increasing by quite as much. Your reader's attention is limited. They're going to glance at a thing and see, what is it saying? What am I supposed to take away? Oh, it's growing but not by much. Or here, oh, it's growing by a lot. If you were an unscrupulous marketer, this would be one of your favorite tricks. If you're a consumer of information, be aware of this one. Okay, now I talked about a non-zero axis. Here's one, finally. Here's one. So this is from the side of a cereal box. This is Rice Krispies. They want to talk about how much sugar is in Rice Krispies versus Apple, Cinnamon Cheerios, and Honey Nut Cheerios. There isn't that much difference. 10 grams and 10 grams versus 9 grams. It's damn near nothing. But they truncated this picture. Right? They stopped it at 7, not at 0. Had they drawn it all the way to 0, you would have seen that the difference in heights isn't much. But here, percentage-wise, the difference between Rice Krispies and Apple Cinnamon Cheerios, man, that looks like, I don't know, a third, 20, 30% difference. Well, it's not actually, but it sure looks that way. So, Kellogg's. Dramatic titles are kind of, and distracting pictures, by the way, are like the clickbait of graph drawing. You won't believe what this graph is going to show you, right? It's like a catchy title, and you don't even like read the content of the article. Same thing with these graphs. Your average reader isn't going to be spending too much time looking at the numbers and trying to see what tricks are being played on them. They want to know, what do I need to know? And so an unscrupulous person will tell them what they want the reader to believe. So they'll give a dramatic title, or they'll have a picture that tells the same kind of story, or that is a distraction from the information. All kinds of tricks like this. So, don't do this. So this is one that kind of violates every single rule. We've got a misleading title. Med school applications plunge. And they sure do seem to be plunging. We've got forced perspective, so this thing is closer to your eyeball. It looks bigger, and the thing that's farther away is definitely smaller. They've also truncated the x-axis, so 45,000 to 35,000. You've left out 35,000 applicants when you drew your picture. So if you were just trying to go by visual proportions here, it looks like now we have 2/3 less med school applications. This thing looks 3 times bigger than this thing over here. But if you just drew a bar chart properly, without having all these weird pictures and telling you what to think and forced perspective and non-zero axes, you wouldn't be fooled. The area trick is something people do with bar charts or bar graphs. The bar should have equal width, and the difference should just be the height difference. But instead, what this person did is they varied not just the width, not just the height, but also the width. So the area here is so much bigger than the area here. Right? If we went from 3 to 6, like take 1990's value and 2000's value, this should be double the 1990. Right? From 3.5 to almost 7. So about double. But man, this area is a whole lot bigger than double because we didn't just change the height. We didn't just double the height, which would have changed the area. We also increased the width. And so we're like quadrupling the area. This is what the information should look like. So we'll take a breather and then we'll look at some more examples of some pretty bad graphs.